Hello everyone, this is Heading Tian. In this video, we are learning chapter 4.4, exponential and logarithmic equations. This video maybe is a little bit longer. Let's see, exponential equation. If the equation has the exponential part, we call that exponential equations. If I have this, for example, I have 2x equals 2 to the 4th. This is also exponential equation. Can you solve for the x? Okay, both sides, they have the base 2. Then the power, they are equal, x equals 4. Now, how to solve the variable x or y in the exponential equation? First step, we're isolating the base. So make sure the base is isolated. Second, rewrite each side of the equation with the same base. Third, equate the exponents. Number 4, solve. Let's see. The first example, if we have 2 to the x equals 16, can you convert to 16 to the same base? Okay, let's see. First, we see 2 to the x is isolated. So we need to convert to 16 to something has the same base 2. Then we have some power. I know that 16 equals 2 to the 4th. Now they have the same base, 2. X equals 4, power the same. Another example, 4 to the 2x minus 1 equals 64. Okay. So exponential part has been isolated. So exponential has been isolated. We need to convert the 64 to the same base, 4. 4 to the 2x minus 1 equals 64. 64 equals 4 cubed. Now they have the same base, 4. 2x minus 1 equals 3. Solve for the x. We can add 1 both sides. 2x equals 4 divided by 2 both sides. We have x equals 2. Let's see, next example. 16 to the x minus 1 equals 8 to the x plus 3. How to convert them to have the same base? If I convert the 6, I can say 6 equals 4 squared. But 8 is not 4 to some power. How to convert them to have the same base? How about 2? The same base 2. I know 2 to the 4th equals 16. 2 cubed, that's 8. So let's rewrite the 2 base. 16 equals 4. 2 to the 4th. And then with x minus 1. We rewrite the base. This equals 6. Then we put to the x plus 3. So here, we multiply the power. 4 times x minus 1. Then we are solving for the x. Distribute the 4. We have 4x minus 4 equals 3x plus 9. Then combine the like terms. We can subtract the 3x both sides. Minus 3x. Minus 3x. We have x minus 4 equals 9. Then add 4 both sides. We have x equals 13. This is a solution. Next one, next example, 49 equals 1 over 7 to the 7th, so to the x power. They need to have the same base, but the right side, we have 1 over 7. Well, if I see 1 over something, I can make a negative power. So let's convert 1/7, only the base part, to the 7 to the -1, because I know that 7 to the -1 is 1/7. And then raise it to the x. 49 equals, relationship is multiplication, 7 to the -x. Can you convert the 49 to the base 7? Yes. 49 equals 7 squared equals 7 to the -x. Now we have 2 equals -x. X equals -2, because we can divide it by 2. Divided by -1 both sides. Then we have x equals -2. All right, let's see next example. We need more space. Okay, so exponent part has been isolated, but how to make them to have the same base? On the left side, it is good because it doesn't have the fraction. So I can bring down the left side is e to the 3x plus 2 equals, if I see 1 over e to the e cubed, so 1 over something means make it to the negative power, e cubed, then raise it to the negative power. So on the right, we have e to the -3. Another side is e to the 3x plus 2. Now the power are equal. 3x plus 2 equals -3. We can minus 2 both sides. 3x equals -5, and then divided by 3 both sides. X equals -5/3. All right, let's see next example. Next example, on the left side, the exponent part has been isolated. That's 9 to the 2x minus 1. But on the right side, we have square root of 27. If I see the root, that means we are raising the 27, the base, to the 1 over, the root is 2, so 1 over 2. Do they have the same base? No, I need to create them to have the same base. 9 equals 3 squared, 3 squared. Then raise it to the 2x minus 1 equals 27 equals 3 cubed to the 1/2. Then we have 3 to the 2 times 2x minus 1 equals 3 to the 3 times 1/2 is 3/2. So exponents are the same. 2 times 2x minus 1 equals 3/2. We need to distribute to the 2 and then combine like terms. We have 4x minus 2 equals 3/2. I can isolate the x, or you can multiply by 2 both sides. So if I want to isolate the 4x, we can plus 2 both sides. 4x plus 3/2, equals plus 2. They are not the same. They don't have the same denominator. So 2 multiplied by 2 over 2. 4x equals 3/2 plus 4 over 2. So 4x equals 3 plus 4 is 7. 7 over 2. Then divided by 4 both sides. Then here divided by 4 means multiply by 1/4. X equals 7 over 8. All right, let's see the property we have learned. So if we have the expression that we need to use the log to help us. So first we need to do the review. if we have the p times log base a to the m's, I can move the p to the power of the m. So p is the power of the m. If we have the natural log, we have the ln, p times ln m. I can also move the p to the power of the m. I have ln m to the p's power. So if we see the form of the expression that I cannot create the same base. So for example, in previous example, we can create both sides, they have the same base. Then I can set the exponent, they are equal, solve for the variable. But now, if I cannot make sure both sides, they have the same base, then I'm using the logarithm expression to help me. So first, we need to isolate the base. Second, take the log or take the ln both sides of the equation. Third, use the log property. Rewrite the exponents as coefficients. Number 4, solve. Number 5, use calculator or approximate the solution. Okay, let's see the example. The first one, 7 to the x equals 60. So both sides I cannot convert to 60 to the base 7. That means I can take the log both sides because the exponent has been isolated. So if I take the log both sides, a common log, 7 to the x equals log 60. If you take the log, you need to take the log both sides. Then can you bring the x to the front? Yes, x times log 7 equals log 60. Remember, here is multiplication. I'm isolating the x. I can divide it by log 7 both sides. We have x equals log 60 divided by log 7. I can use the calculator to find this. Let's see, calculator. We have log. So on the top, maybe I can use more parentheses. On the top, I have log 60 parentheses. This parentheses that carries the 60, and then another parentheses that carries the top numerator divided by denominator is log log 7, close the parentheses, close the parentheses. Hit enter. So I'm having 2.1040. If we keep 3 decimal places, so I'm keeping 2.104 because after the 4 is 0. So I can ignore the digits after the 4. So I'm having 2.104. Okay, how about next one? Next one, the exponent has been isolated and the 40 cannot be converted to the base 2 or base 8. So I can use some method that is take the log both sides. You can take the ln. So if I want to take the log, that's a common logarithm. Log 40 equals log 8 to the 2x minus 1. Why I'm taking log? Because I know I can move the 2x in front of the log. Then I can solve for the x. So log 40 equals 2x minus 1. You must bring all of them to the front, not to the 2x, because all of them at the exponent part. Log 8. Then I'm solving for the x. I can divide it by log 8 both sides. They can be cancelled. So log 40 over log 8 equals 2x minus 1. I need to isolate the x plus 1 both sides. So we have log 40 over log 8 over equals, sorry, plus 1 equals 2x, then divided by 2 both sides. So x equals log, on the top we have a fraction. We have log 40 over log 8 plus 1 over 2. Let's use calculator to find this solution. All right. So on the top, I'm using a parentheses, contain all the numerators. So let's try just to use log 40, close the parentheses, divided by log 8, close the parentheses, plus 1. These are all the top numerator, divided by 2. Okay, we got 1.386988016. If I only keep 3 decimal places, so we'll have 1.387, because after the 8 we have 9. 9 is greater than 5, so we have 1.387. All right, let's move on to see next 2 examples. Next 2 example, is the exponential part has been isolated? No. Then in this question, we have -7 here. We need to add 7 both sides. Then there's the exponent part has will be isolated. Add 7, e to the 2x plus 1 equals 20. Then I can take the ln both sides. I can take the log, but I prefer to take the ln because I see the e and ln can be cancelled. So ln e to the 2x plus 1 equals ln 20. Then I can bring the 2x plus 1 in front. 2x plus 1 times ln e equals ln 20. What is ln e? That is 1. 2x plus 1 equals ln. I can minus 1, 2x equals ln 20 minus 1. X divided by 2 both sides. X equals ln 20 minus 1. All right, we need to use calculator. Here. We have on the top, I use the parentheses. So we have ln 20, close the parentheses, contain the 20, because minus 1 is outside of the ln, not inside of the parentheses of the ln. Minus 1, close the parentheses, these are the tops, divided by 2. We have 0.9978. We keep 3 decimal places. We are having 0.998. All right, let's see next example. Next example, so exponential part haven't been isolated. We can minus 11 both sides. We have 5 to the 3 minus x equals 24. Then take the, so this time you can take the ln. If you take the log, is totally fine. 3 minus x equals ln 24. So let's bring the 3 minus x in front. We have 3 minus x times ln 5 equals ln 24. And then I'm isolating the x. I cannot have ln 5. So both sides divided by ln 5. 3 minus x equals ln 24 over ln 5. So I can I can move the x to another side and then move the ln 24 divided by 5 another side. So let's say plus x both sides. Then there's no x. X equals ln 24 over ln 5 plus x. Be careful, this is not x, this is 3. Then minus ln 24 over ln 5 both sides. That's x. And use the calculator to find the value. So we have 3 minus, on the top we have ln 25, close the parentheses, divided by, so I don't need to have this parentheses, delete it. Okay, divided by ln 5, close the parentheses. Why I'm having 1? Oh, I see. I copied the wrong thing because you see here shouldn't be 25, it's 24. So be more careful. All right, let's change our data in the calculator. So copy it. So I moved my cursor, highlighted the expression, and then hit enter and move my cursor, corrected the 25 and make 24. All right, here we are having 1.02536 something. So keep 3 decimal places, 1.025. Ignore the digit after 5 because after 5 we have 3. So 3 is less than 5. So x, what is that? I forgot. 1.025. All right, let's move on to see next 2 examples. Okay, I can. All right, let's see. Both sides, I cannot convert them to the same base. So I'm taking the log or ln both sides. Maybe this time we can try ln because ln and the log, they can be found from the calculator. So let's try. Take the ln both sides. ln 4 to the 1 minus x equals ln 3 to the x plus 5. I can move these powers to the front. 1 minus x times ln 4 equals x plus 5 times ln 3. This one, we need to combine the x here. They are all in the parentheses. We need to clear the parentheses. So let's clear the parentheses. We distribute ln 4 in the parentheses. So we can do the distribution. Right. We do the distribution. Should have a 3 here, right? Do the distribution inside of the parentheses. We're having ln 6 times ln 3 plus 5 times ln 3. The x term here and here, I can combine all the x term. If I want to keep the first positive x, I can add x ln 4 both sides. We have ln 4 equals x times ln 3 plus x times ln 4 plus 5 ln 3. Then we need to combine all the number part together. I can minus 5 times ln 3 both sides. So we're having ln 4 minus 5 times ln3 equals, so equals this because these two canceled. We can factor out the x. In the parentheses, we have ln3 plus ln4. Isolating the x, I can divide it by ln3 plus ln4. So here and here has been cancelled. X equals ln4. Not good looking. So make a better expression. We are having ln4 minus 5 times ln3 divided by ln3 minus ln4. Let's use the calculator. Here. Okay, we are having on the top, I'm using parentheses because on the top we have two terms, ln4, close the parentheses, minus 5 ln3, close the parentheses again. So all of these are the tops divided by, we have two terms at the bottom. So I use a parentheses, ln3, close the parentheses, minus ln4. So let's see if I have any mistake because sometimes I make mistake. So here is plus, right? I shouldn't have a minus. So let's come back to see the expression, change it. So this is plus. And then hit enter. So if we keep 3 decimal places, we will keep 1.653 because after 2 we have 6. 6 is greater than 5. We must add 1 digit at the third decimal places. So we're having a really bad memory. I think it's 1.6 something. 53. Okay, we have. Let's see. Both sides they have the exponential form, and they have no same base. Where we need to take the log or ln both sides. So if I'm taking the ln both sides, ln3 to the x plus 1, another side ln to the 7 to the 2x minus 5. Then I can bring the power to the front. X plus 1 times ln3 equals 2x minus 5 times ln7. We need to combine all the x part. We need to distribute this ln3 and ln7. X times ln3 plus ln3 equals 2x times ln7 minus 5 times ln7. So let's combine these two. If I want to keep the positive x, it doesn't matter which side I want to keep the x. If I want to move all the x to the left, I can say minus 2x ln7 minus 2x times ln7. So we have x times ln3 minus 2x times ln7 plus ln3 equals negative 5 ln7. Then we need to move ln3 to another side, minus ln3 minus ln3. We have x times ln3 minus 2x times ln7 equals negative 5 ln7 minus ln3. Then can you factor out the GCF x? Yes. Factor out the x, we have ln3 minus 2 times ln7. equals -5 ln7 minus ln3. Then both sides we divide it by ln3 minus 2 ln7. So this part canceled. X is about, so we can use calculator to evaluate this part. So okay, clear the screen. And on the top, we have -5 ln7 close the parentheses minus ln3 close the parentheses and then close the parentheses again. That's the top. Divided by, so bottom we have two terms. We put a parentheses there. ln3 close the parentheses. Then minus 2 times ln7 close the parentheses again. Hit enter. So we're having 3.876. So we need to keep 3 decimal places. We are having 3.877 because the fourth digit is 6. 6 is greater than 5. So we need to add 1 at the previous digit. We're having 3.867. Is that 3.867? No. We have 3.877. Here is not 677. All right, we finished this part. Let's see. Move it down a little bit. What did I do? Okay. Yay. All right. So if in the expression, one side is logarithm function or logarithm form, another side is constant. So for example, if the equation has a form like this, how to solve for the variable from this form? First, we can combine all the logs using the log property. Make sure they have the same base. So I can combine the m and n. So if I don't have the constant here, I'm having log base b. Inside we have m times n, and then equals that constant triangle, then convert it to the exponential form. So it's so messy. All right, solving the form like this, we use the combine logs using the log property. Second, if the coefficients do not equal to 1, then use the log property. So move the p to the exponent part. Number 3, your equation should have the form of log base b, d equals constant. Number 4, we write the equation in the exponential form. So b to the constant power equals d. And the next step, solve for the variable. Number 6, check your answer. Here is important. For this step, we must check the solution. Why? Because sometimes here, we know that everything in the parentheses must be greater than 0. If the solution will make this part negative, that's undefined. So we must ignore that solution or keep one solution if make sure we have the positive in the exponent part. Oh, sorry. So in the parentheses of the log. All right, let's solve the first example. The log part has been isolated, and we need to convert it to the exponential form. We are having 5 squared equals 3x plus 2. Then we can solve for the x. 5 squared is 25. 25 equals 3x plus 2. We can subtract the 2 both sides. We have 23 equals 3x divided by 3 both sides. X equals 23 over 3 because cancelled. And then we are moving it back to this equation. Check. When the x equals 23 over 3, bring it back to the equation. Log base 5. 3 times x is 23 over 3 plus 2. Yes, this is positive. Make sure that equal to 2. Let's check. Log base 5 to the 3 cancelled. We have 23 plus 2, that's 25. We have log base 5 to the 25. And 25 equals 5 squared. And log 5 and 5 cancelled. We have 2. Yes, it's equal to the right-hand side, which right-hand side is 2. Yes, they are equal. And also inside of the parentheses of the log is positive. So x equals 23 over 3. It is the solution for the equation. So let's see next example. Next example, ln part has been isolated. I can convert it to the exponential form. So what is the base of ln? E, because ln is log base e. So e is the base to the third power equals 4x plus 2. Solving for the x, I can minus 2 both sides. E cubed minus 2 equals 4x. And then both sides divided by 4. So x equals e cubed minus 2 over 4. In your homework, you can give the solution like this. You don't need to convert to find the exact solution. If the question asks you find the exact solution, you can use the calculator. You see on the top we have the e. How to find the e? You click second, you click ln. That's the e to some power, e cubed. Then move the cursor, minus 2, close the parentheses, divided by 4. And then you have the solution. If the question asks you keep how many digits, decimals, you just count and round it to the specific decimal places. If the question doesn't ask, you just keep the e. All right, next example, if we have log x plus 2 plus log x minus 1 equals 1. How to solve this? Solving this, we can combine these two logs together and then convert it to the exponential form. They have the same base, 10. So we are having log, same base. Inside of the log, we have x plus 2 multiplied by x minus 1 equals 1. Now we have one logarithm form. That means I can convert it to the exponential form. What is the base? For the common log, 10. 10 to the first power equals x plus 2 times x minus 1. And then we need to solve for the x. If this one equals 0, I know how to solve it. Each factor equal to 0. But now it's not 0, it's 10. What should I do? I should FOIL the right side and then combine like terms. Make sure one side is 0. Factor the trinomial using the AC or AM method. Let's FOIL the right side first. X times x, x times -1, x times x, x squared. X times x, -1, negative x. 2 times x plus 2x. 2 times -1 is -2. Okay, my screen doesn't work properly. And then combine like terms. We have x squared. So these two are like terms. Plus x minus 2. Minus 10 both sides. We have 0 here. X squared plus x minus 12. And then what method I'm using to factor this? I can use AM method. Here's A, here's M. M is -12. Find two factors. Addition make a 1. There are 3 and 4. And we are making positive 1. Addition more positive 1. We have -3, positive 4. So we're having 0 equals x minus 3, x plus 4. The first factor equal to 0, x minus 3 equal to 0. Second factor equal to 0. Solve for the x, add 3 both sides, x equals 3. And minus 4 both sides, x equals -4. We have two solutions. Can I keep both? No. So this part we must check the solution. So we can keep make some space here. Okay, let's say check. Okay. So check if the x equals 3 and our equations here. So log 3 plus 2 plus log 3 minus 1. Is that 1? Let's see. We have log 5 plus log 2. We can combine them. We have log 10. So log 10, the base is also 10, is 1. Is that the right hand side? Yes, it is. So x equals 3 is one solution. How about x equals -4? So let's check x equals -4. Put it in the equation log. X plus 2 is -4 plus 2. Plus log -4 minus 1. All right, I don't need to move on because in the parentheses we have -4 plus 2. Is that positive? No, that's negative. Negative means this part is undefined because we do not have negative in the parentheses of the log. And another part, so in the parentheses we have -5. It's still negative. It's undefined. That means we cannot have x equals -4. We only have one solution, which is 3. All right, let's do the next example. Next example, do we have only one logarithm expression? No, we have two. But luckily, these two logarithm expression, they have the same base 2. That means I can combine them. So in the middle, we have minus. That means when I combining these two logarithm expression, inside we have division. So x squared minus 3x divided by x plus 2 equals 2. Now we have only one logarithm expression. We can convert it to the exponential form. 2 squared equals x squared minus 3x divided by x plus 2. Then we have 4 equals x squared minus 3x divided by x plus 2. I can multiply by x plus 2 both sides. So this part canceled. We can distribute the 4. We have 4x plus 8 equals x squared minus 3x. We combine like terms. How about moving everybody to the right? That's a good idea, right? So we minus 4x minus 8 both sides. I have 0 equals x squared minus 7x minus 8. Yay, we can use AM method because here is leading coefficient is 1. So we can use AM method. M means multiplication. Let's see, -8. Find two factors. Addition make a -7. What are they? So 1 and 8. 8 is negative. Then the addition can make a -7. Multiplication, -8. So the factored form is x plus 1 times x minus 8. First factor equal to 0. Second factor equal to 0. We can solve for the x from this step. So x, so -1 both sides, x equals -1. And then so plus 8 both sides, x equals 8. Then we need to check the solution. So put the check here. When the x equals -1, we have log base 2, -1 squared minus 3 times -1 minus log base 2, -1 plus 2. It is really cool because inside of the parentheses is positive. We may keep this negative number. So log base 2, -1 squared is 1. 1 minus 3 times -1 is 1 plus 3. Minus log base 2. -1 plus 2 is +1. So we have log base 2, 4 minus log base 2, 1. That is 0 because every time you see a 1 here, 1 itself in the parentheses. Can I change the color? Highlight it. So if I have 1 here, I always have a 0 here. Okay. And then we have log base 2. What is the 4? 4 is 2 squared. 2 to cancel. We have 2. Is that the right-hand side? Yes, it is. So we keep this solution x equals -1. How about to check x equals +8? So let's check x equals 8 and put it into the equation. Base 2 and 8 squared minus 3 times 8 minus log base 2. 8 plus 2. The log base 2, 64 minus 24 minus log 2 base 2. 8 plus 2 is 10. And be careful here. I forgot what I should be careful. Okay. I remember that. Be careful. Are these value in the parentheses positive? If they are positive, that means yes, they could be the value because if negative is undefined, so it's positive. So that should be my solution. All right, both of them negative in these two logarithm form. So we have log base 2, 40 minus log base 2, 10. We need to combine them because here is division, here is subtraction. They have the same base, which is 2. 4 divided by 10. We have log 2 base 2, 4. That is log base 2, 2 squared. That's 2. That's the right-hand side. Yes, we got two solutions. One is x equals -1. Another one is x equals +8. All right, let's come to see combine logs using log properties. If both sides we have the logarithm form, and each element or each terms in the expression in the equation, they are all has the log. So what method I'm using? First, I need to combine the logs using the log properties. And second, if the coefficients do not equal to 1, then use the log properties. So move the p to the top of the m, put it here. And then number 3, use now equation should have the form of log base b d equals log base b c. They have the same log base b part. So c equals d or d equals c. Next step, solve for variable. Number 6, check your answer. Let's see the first example. So both sides, they all have the log base 2. So I can combine the left side, make it into the same one log base 2. This one is addition. That means we have log base 2. X times x minus 5 equals log base 2, 6. They have same log base 2. So x times x minus 5 equals 6. I need to solve the x, distribute the x, and combine like terms. X squared minus 5x equals 6. So subtract the 6 both sides. Minus 6, x squared minus 5x minus 6 equals 0. I can use AM method. Solve this. Here is A, here is M. M is -6. Find two factors addition to make a -5. What are they? We can say one factor is 1, another factor is 6. 6 is negative, so addition -5. We're having x plus 1 times x minus 6. We have two factors. First factor equal to 0, second factor equals 0. So solve these two equations, minus 1 both sides, x equals -1. And add 6 both sides, x equals 6. And then we need to check our solutions. I cannot guarantee they are my solutions. So let's use a space here. Check. First one, I'm checking x equals -1. In the equation, I'm having log base 2 times -1 plus. So can I continue? I don't need to do that because look at here. Here is negative. That means undefined. I don't need to move on. So if I move on, -1 minus 5, here is also undefined. This is positive. Doesn't work. All right, this is also negative, so undefined. So I don't need to keep on moving. All right, I can cross out the solution here and do another check. Check x equals 6. So in the equation, we have log base 2, 6 plus log base 2, 6 minus 5. So this is left side. We have log base 2, 6 plus log base 2, 1. And I know that this part is 0. So we have log base 2, 6. Is this one the right-hand side? Yes, it is. You see log base 2, 6. So, filter is slow. I think I'd better to save and then record another video because this video is so long. All right, so we have only one solution, x equals 6. So next video, we will do the next question. Okay.